Hello and welcome back to Chapter 8. Let's start by doing an exercise about the equivalent uniform annual cost. Now let's say that you have these three options. Recall that the equivalent uniform annual cost is basically equal to the annualized initial cost minus the annualized salvage value plus the annualized costs of maintaining and operating the asset. So all these items are in annuities. We have these three potential machines we are interested in. Machine A requires an initial cost of $300 investment, has a salvage value of $100, and the annual cost of maintaining and operating machine is flat at $50 per year. Option B, there's an initial investment of $270 and the salvage value expected of $80, and the annual cost of operating and maintaining the machines are $70 in the first year and then expected to grow by $10 per year. And then there's a third machine, machine C, which is the most expensive, requires $400 investment, has a salvage value of $180, and then the annual cost is of maintaining and operating the machine is $40 in year one and then grows by 5% per year. Our minimum acceptable rate of return is 10%, the expected life is 3 years, and let's say for the sake of it, like in a real life situation, that our budget is $320. So the first thing you would do is check out if you have money to buy any of these machines. And you would conclude that, okay, I don't have money to buy machine C. So it's not even worth it further consideration. So we are left with evaluating machine A and machine B. These are all negative cash flows. Being negative cash flows means that there is no profits. The only thing that there is a potential positive here, only positive cash flow in this kind of situation is the salvage value that we're going to collect once we sell the machine. But all the other are negative cash flows. There's the initial cost and there's the average cost of maintaining the machine. These are all negative cash flows. So we're going to select A or B depending on which one gives us the overall lowest equivalent uniform annual cost. Once we find that, we also gonna be able to identify how many years we should keep that machine that provide us the lowest EUAC. Note that from the information we have here just a moment ago, the interest rate 10% and the expected life of each machine is 3 years. So that means we're going to have to do 3 computations for each one of these machines. How much is going to cost me per year if I keep machine A 1 year, 2 years or 3 years. So that's 3 computations. And then the same logic for machine B, another 3 computations. So in total we're going to do 6 computations. And then we'll find where is the lowest equivalent uniform annual cost. So for machine A, the equivalent uniform annual cost, if I keep it just 1 year, it's equal to, remember the formula of annuity, so the present value of an annuity is equal to 1 minus 1 plus I to the power of minus n divided by I, which means that the annuity then is equal to the initial cost, the present value, times I 1 minus 1 plus I to the power of minus n. So this is the formula we're going to use here to transform this initial cost into an annuity. So we're going to have 300, not negative 300 because this is already costs, right? So pay attention to the signs. This is 300, not negative 300, even though it's the initial cost. And then multiply by the discount factor, which is 0.10 divided by 1 minus 1 plus 0.10 to the power of minus 1, because I'm considering just keeping it 1 year, So that's the initial cost annualized. Then I'm going to reduce this cost by collecting those 100 whenever I sell it. So in this case, we're talking about a future value that we want to transform into an annuity. And given that the future value of an annuity is given by this formula, then the corresponding annuity can be computed using this transformation. So that's what I'm going to use to annualize those 100. So negative 100 because I'm offsetting the cost, right, by getting a positive cash flow. So basically the signs here are reversed because we are focusing on costs. So negative 100 times this discount factor, 0.10 divided by 1.1 to the power of 1, because that's just assessing how much it's going to cost me if I keep it just 1 year, right? So the power of 1, then minus 1. So we took care of the salvage value. And now we're going to add the other cost, which is the maintenance and operating cost, which in this case is flat. It's flat at $50 per year. So this is the formula we're going to use to compute the equivalent uniform annual cost. And then if we decide to keep it 2 years, the formula is the same. The only thing that we do is to update the n. Right? So let's write down that here so that you see how worth it is to program the formula on your machine for future use. So we're going to find this value soon. So the equivalent uniform annual cost, if we keep it 2 years, is basically equal to 300, 0.10, 1 minus 1.1 to the power of negative 2. Okay, that's the n. Then we take out the annualized salvage value, 0.10 divided by 1.1 to the power of 2. Then minus 1 plus 50. 50 remains flat because it's a flat annuity. This is per year. So then we are left with computing for what if we keep the machine 3 years? 1 minus 1.1 to the power of minus 3 minus 100, 0.10, 1.1 to the power of 3 minus 1 plus 50. So computing these formulas, you would find that if you keep the machine for 1 year, your cost is 280. If you keep the machine for 2 years, your cost is $175.24 per year. If you keep it 3 years, the equivalent uniform annual cost is 1.40.42 per year. So if this was the only machine you had to evaluate, your recommendation would be, okay, keep it for 3 years, because that's where our equivalent uniform annual cost is minimized at a cost of $140 per year. If you keep it to 3 years. If you only keep it 2 years, your cost is $175 per year. If you keep it just 1 year, your cost is $280. So the goal is to minimize the equivalent uniform annual cost. When you find the minimum, you also find how many years you should keep it. In this case, we'll keep it for all its expected life, but that will not always be the case. Depends on the circumstances of these annual costs in particular. So from here we should retain that the minimum was achieved at this point. So that's what I'm gonna put here to remember when we look at the case of machine B. So for machine B, just recall that we had an initial cost of $270 the salvage value of 80, an annual cost of 70 in year 1, but growing by $10 per year. So we would compute the equivalent uniform annual cost when keeping it 1 year would be equal to 270 times the interest rate divided by 1 minus 1.1 to the power of -1. Then we would reduce these by the salvage value, so using the annuity given the future value. So that'll be 80 times 0.10 divided by 1.1 to the power of 1 minus 1. And then we have this growing annuity, right? So how would we take care of that? Well, basically note what's going on. 0, 1, 2, 3 years, right? And this was from chapter 1. We learned the linear gradient. Let's just do a mini review. So what we have going on here for the maintenance costs is that they are 70 in the first year, but then grow by 10 in the second year, and then another 10 by the third year. Right. So we have these bases and this growing component that we want to flat out. So we're going to take care of them separately and then add them up, as we learned in chapter 1. So remember, so here I'm going to have the 70 flat, and now I need to annualize this. That's the A given G formula on page 21. So to annualize that, the gradient is 10. Let's just write here the formula so you remember. A given G, it's equal to 1 over the interest rate minus n divided by 1 plus I to the power of n minus 1. So we're going to transform these into something that happens here, here, and here. Right? So that's why we can add that up. We're going to have the gradient, which is 10, then multiplied by 1 over the interest rate, then minus n, in this case n is 1. Students usually forget that this here is n, so pay attention to this numerator. And then divided by 1.1 to the power of 1, the n, minus 1. And that we need to compute. Then what if we keep machine B for 2 years? We're gonna replicate this formula, just updating the n's. So if we are to keep the machine for 2 years, then we have to compute this formula for when n is equal to 2. So all that I'm doing here is updating the n. So here now it's minus 2. N is 2, so I now have that n equal to 2. Then this component, the salvage value analyzed, spread out across 2 years. So the n updated to 2 minus 1, then plus 70, then plus the gradient when these will be allocated across 2 years. So the n here is 2 divided by 1.1 to the power of 2 minus 1. And since this machine is only expected to live for 3 years, its expected life, then we need to do just one more computation where the n is updated to 3 and update it to 3. So we just need to program it once and then get the values for the varying years. So if we keep this machine for 1 year, the cost is $287. If we keep it for 2 years, the cost is $192.24 per year. If we keep it for 3 years, the cost is $163.77. For this machine B, the equivalent uniform annual cost is minimized at year 3, meaning that if we are not comparing it with machine A, if there was just machine B, we would say, okay, keep machine B for 3 years, and by doing so your annual cost is going to be about $164. However, in this more complex exercise, we have 2 machines to choose from, one or the other. And given that the equivalent uniform annual cost is lowest when we're talking about machine A, because the lowest it gets for B is 163, our conclusion would be go with machine A and keep it for 3 years. That's where your equivalent uniform annual costs are minimized. That's the global minimum across all options in this scenario. Of course, if you have more machines, you would repeat this rationale for all the machines and find where was the lowest EUAC across all machines. When you find it, then that's your recommendation about the machine you should buy and how long you should keep it. So that's it about equivalent uniform annual cost, and therefore you are ready to do the quiz.